Okay, we're going to continue on with the 2015 AP Calculus Practice Exam. We are on multiple choice number 25, and that is page 19. The page number 19 will appear on the bottom of that test. So number 25 says, what is the limit as h approaches 0 of sine of pi over 3 plus h minus sine pi over 3 over h? And what you've got to recognize is this is from the beginning of chapter 2. This is just stating the definition of the derivative. Okay, and that's going to be f of x plus h minus f of x over h if you take the limit of that as h approaches 0. In our book, instead of h, we use delta x. Okay, so looking at this, what is f of x? Well, f of x is just the sine of pi over 3. So they're just trying to see, do you recognize this is the definition of the derivative, and can you pick out what f of x is from this? Okay, so what's f prime of x then? Well, what's the derivative of sine? It's cosine. So cosine of pi over 3. If you can remember your unit circle, what's the cosine of pi over 3? It is 1/2. And that is answer B. Okay, let's look at 26. So 26 says an object moves along a straight line so that the velocity v of t is equal to 2 cosine 3t. What's the distance traveled by the object from t equals 0 to the first time that it stops? So to get the distance, we need to get s of t, and the way you're going to get that is by integrating 2 cosine 3t. All right, and you're going to integrate that. Let's say it starts at 0, and you're going to integrate it to some point, and that point is where does it change direction? We've got to figure that out. Okay, so velocity changes direction when this goes from positive to negative. So when cosine is equal to pi over 2. Because cosine of pi over 2, all right, well, right, when you have here cosine of pi over 2, not cosine equal to pi over 2. So when cosine, sorry about that, of when 3t is equal to pi over 2. Because cosine of pi over 2 is 0. So that's where it's going to go from positive to negative. That's where it's going to change direction. Okay, so if 3t is equal to pi over 2, then t is going to be, divide both sides by 3, pi over 6. So we need to integrate this from 0 to pi over 6, and that'll give it to us. Okay, so the antiderivative of cosine 3t, that'd be sine 3t. You could u substitute this. You know you're going to need a 1/3 out front. So I kind of, instead of u substituting it, kind of use my brain on that, but feel free to make u 3t. We can't forget about that 2 out front also. But if you take the derivative of 1/3 sine 3t, you'll get cosine 3t. So that's going to be, we're going to evaluate 2/3 sine 3t from 0 to pi over 6. So really the tricky part, I'm sure you remembered you're going to have to integrate v of t to get the distance, to get s of t. But the tricky part is what are our limits of integration? And it's where this thing goes from positive to negative, and that's at pi over 6. I'm plugging pi over 6 into t. That's going to give me pi over 2, where cosine is 0. So that's going to be 2/3 sine 3 times pi over 6 would be pi over 2 minus 2/3 times the sine of 0. Right, sine of pi over 2 is 1, and sine of 0 is 0, so that's just going to be 2/3. And that is C. So that one's a little tricky. I know you know how to do the calculus. You just got to figure out, well, what am I integrating from and to on that one. All right. Okay, so I don't want to rewrite this table. So just look at the next page on number 27. And we'll be referring to this table. So it says the table gives the selected values for a differentiable and decreasing function f and its derivative if the inverse, f to the minus 1 is the inverse, what is the value of the derivative of the inverse at 2? Okay, so you have to remember, and we did a worksheet on this back, it was in chapter 5, that the reciprocal relationship. Okay, so if the derivative in the table, if f prime of x is equal to -8, then the inverse, the derivative of the inverse, so we'll call that f to the minus 1 prime, of 2 is the reciprocal of that, -1/8. I think that'll be enough to remember for inverses. If you can just remember that reciprocal relationship, you can probably nab the answer. So that is B. Okay, 28. So we've got, this is the famous ladder problem. And we did related rates. Okay, so we've got this situation here. All right, so we've got a ladder, a wall, theta, okay, is our angle. The ladder is 15 feet long. We'll call this Y. And we do have to figure out what the x value is. But the ladder is sliding down the wall, and it tells us the rate that it's sliding down is 2 feet per second. Okay, so since it's going down, we're going to call that -2. So we want to know at what is the rate that theta is changing. All right, so we want d theta dt. What do we know? Well, we know dy dt is equal to -2. Now, if you accidentally make that +2, you'll just get, the answer you get will just be a different sign than the correct answer, and that still may be okay. You can figure it out. All right, relate. When we're doing related rates with an angle, you want to use the trig function where you use the fixed value, which the ladder is always 15, and you want to use the side of the triangle or whatever geometric shape it is that you know the rate for. So that's going to be y. We don't know the rate for x. Okay, we can figure out, we're going to be able to figure out x in a minute, but we don't know the rate for x. So we would have opposite over hypotenuse. So we're going to use sine. Sine theta is equal to y over 15. And then we need to dt that. So that would be cosine theta, d theta dt, is equal to 1/15 dy dt. So d theta dt is equal to 1/15 dy dt over cosine theta. Okay, now we're going to need to figure out some things. It says when the base of the ladder is 9 feet from the wall. Okay, so now we gotta figure out what is y. So y, Pythagorean theorem, is going to be the square root of 15 squared minus 9 squared. All right, so you don't have a calculator, so you gotta kind of muddle through this, but that's going to be 225 minus 81. That's the square root of 144, which is 12. All right. So that's actually the same as the 345, right? Just in a different ratio, 9, 12, 15. All right, so we'd have let's plug this in. Cosine, what is cosine theta? So cosine is going to be adjacent over hypotenuse, so 9 over 15. So we're going to need that in a minute. So we've got 1/15 times negative 2 over 9 over 15. So that's negative 2/15, and flip and multiply 15 over 9. The 15's cancel, and you got negative 2 over 9. And that is answer A. So they finish it off with a little bit of a tough one, but you have seen this ladder kind of problem before. All right, so. All right, we're going to switch over to the calculator portion. So have your TI-89 out, although the first few of these, we won't really need it. Okay, number 76 says that the function p of t models the population of the world in billions of people per year, where t is the number of years since January 1st, 2010. So t starts at January 1st, 1/1/2010. Which of the following is the best interpretation of p prime of 1? So t, what it says, so that would be t naught. Okay, our initial t. So t is the number of years since January 1st. So p prime of 1 would be 1 year later. That'd be 1/1/2011, right? And what does a derivative tell you? It's the instantaneous rate of change at that date, 1/1/2011. Instantaneous rate of the change of the population. So let's look at the possible answers. A says 1 month later. Okay, so, well, that's not what it said. It said it's the number of years for t. B gives us exactly 1 year later, and it says the population of the world was increasing at a rate of 0.076 billion people per year. And that's exactly what p prime of 1 is. If it's 0.076, that's what it's telling you, so it's going to be B. Let's look at the other options real quick. C, saying that the population is 0.076. Well, no, that would just be p of 1, not p prime of 1, so it's not C. D says from January 1st, 2010 to January 1st, 2011, the population of the world was increasing at an average rate. All right, that'd be the slope of the secant line. That is not the slope of the tangent line for D, so it's not D. And then E, when the population of the world was 1 billion people, the population of the world was increasing at a rate of 0.076 billion people per year. That has nothing to do with anything. The 1 billion people, I mean, they're kind of like writing tests like I do, and you just make up one, just pull it right out of your caboose. All right, so that is number 76. 77 refers to this table right here. I'm not going to write that out. But it says let f be differentiable function with selected values. What is the average rate of change of f between 0 and 10? All right, average rate of change is the slope of the secant line. It has nothing to do with calculus. So that's just going to be the change in y over the change in x. y2 minus y1 over x2 minus x1. Well, what is this? If we're going from 0 to 10, what is y2? It's negative 20, looking at the table. What is y1, our first y, when x is 0? It is 5. And then the bottom is 10 minus 0. So negative 25 over 10 is going to reduce to negative 5/2. And that is option B. All right, the key is the language, not instantaneous rate of change, but average rate of change. All right, I think I can fit number 78 on here. So 78 says, the rate at which motor oil is leaking from an automobile is modeled by the function L, defined by L of t, is equal to 1 plus sine t squared. L of t is measured in liters per hour, and t is measured in hours. How much oil leaks out of the automobile during the first half hour? All right, your calculator, you're going to be using your calculator. How much? You're accumulating something. You're adding something up. Do you take a derivative or do you integrate? All right, you integrate, adding something up. So we're just going to integrate, and we want to know how much in the first half hour, and time is in hours. So that's going to be 0 to 0.5 of 1 plus sine t squared dt. You're going to place that in your calculator, and you will get 0.541. Give it a try. And that is answer D. So you want to practice using that calculator. Don't let those skills diminish. Okay, we're going to do a couple more, and we'll call it a video. So let me erase. Number 79. Okay, 79 is referring to this table here. Okay, so I'm not going to write that out. Just follow along with me. Got the table above gives value of the differentiable functions f and g and their derivatives at x equals 0. If h of x is equal to f of x over g of x, what is h prime of 0? All right, well, you're not really used to this, but we got to get h prime, and this is a product rule. So product rule bottom, g of x, not product rule, I'm sorry. This is a quotient rule. Quotient rule. Bottom times the derivative of the top, f prime of x, minus the top, f of x, times the derivative of the bottom, g prime of x, all over the bottom squared. Now we just plug the numbers in from the table. So h prime of 0, because all those numbers are at 0. So what is g of x? It's 2. What is f prime of x? It's 4. What is f of x? It is 3. What's g prime of x? Pi. What is g of x? It's 2. We got to remember to square it. So that's 8 minus 3 pi over 4. That is option A. All right, boom. Now number 80, I'm going to go ahead and draw the graph. Draw a poor version of it anyway. So we've got 1 and we've got 2. We go, and this is the graph of f prime, graph of a derivative. So boom, and going way down here, boom. So it says the figure shows the graph of f prime between 0 and 2 is included in the interval. Where is there an absolute minimum? Well, a minimum occurs. All right, you say what you think the answer is first. All right, so a minimum occurs where the graph of the derivative f prime goes from negative to positive. Where does that occur on this graph? Well, at 1, it's positives and negatives, so that'd be a max. And it goes from negative to positive at 2. And that is option E. That will do it for this video. So far, I don't think things are too bad. So happy studying, and we'll see you next time.